4.5, prove triangles congruent by ASA and AAS. So once again, what do you think ASA stands for? That's right, it's angle, side, angle. And AAS, angle, angle, side. Now you might say, well, aren't those the same thing? No, there is going to be a difference, and it's important we see the difference, and it comes from how your triangle gets marked. So it's really important that we mark our triangles with everything we know and then look carefully to see the relationship between those to see if it's angle, side, angle, or angle, angle, side. All right, one vocab for us today, flow proof, a proof that uses arrows to show the flow of a logical argument. All right, we're going to treat the flow proof just like we do the paragraph proof. I'm going to show you some examples. We're going to kind of walk through them today with a few examples. And if you like that method, you're welcome to use it. If you don't care for that method, you don't have to use it. But once again, just like the paragraph proof, the two-column proof, it's always good to see that there's different ways we can do it, and then you can choose your preference from there, okay? So let's look first at our first angle, side, angle postulate, okay? And again, I kind of write in the margin some ideas to keep in mind because that will help us. I need an angle, side, angle in order with no gaps. So it says if two angles and the included side, that means the one right between the two angles, which is where we get the angle, side, angle with no gaps, are congruent to two angles and the included side of a second, then the two triangles are congruent. So I have angle A congruent to angle D. I have AC down here congruent to DF. And angle C congruent to angle F. That means that triangle ABC, notice the way we order we go, so I have to go the same way, is congruent to DEF. And the reason is by angle, side, angle. Okay? Notice it goes angle, then the side, then the angle, no gaps. Angle, side, angle. Okay? Right away, I'm going to go right into the second method so we can see, hopefully, the difference here. This one is angle, angle, side, and you'll notice I even wrote here angle, then there's a gap, then it's an angle, then a side in order. So it says if two angles and the non-included side, that's super important. So it's not the side between them, but one of the outside sides of a triangle are congruent to the two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So I have angle A with angle D again. You'll notice they use about the same picture from before. Angle C this time with angle F, and side BC and side EF. This is the only one of our methods that has this gap. So now triangle ABC, once again the order goes this way, is congruent to triangle DEF. And this time the reason, if you look at it, I have an angle, then a gap, an angle, and a side. Angle, angle, side. Okay? So this is by angle, angle, side. The difference is, okay, and let me draw you kind of two in the margin. This one up here and this one here. This one was angle, side, angle. Right in between the two angles is a side. This one's angle, angle, side. So the side is not between the two, but outside of the two. That's the difference between an angle, side, angle, and an angle, angle, side. So we have to be careful, and we take them carefully, and we check them. And it's all about how the picture is marked. Remember, it's not how the proof goes, because I can throw any ingredient into my from my recipe in any order. It's how the picture looks at the end. All right, so let's peek at these up here. And as you see this here on this page, I'm going to just tell you that when we get to the quizzes and tests, I'm going to have like a page or a column of just these kind of pictures where you decide how they're congruent. Okay, so on this one, I have some angles marked. Now, I want to just kind of give you a hint. As the more we get into these proofs, the more the markings are the key thing, okay? So what are things you can mark, okay? And that's going to be important to know what else can we mark so we can do this. Okay, so some things to look for. Vertical angles, okay? If your triangles are joined and there's an X there, look for vertical angles. That's often a set of angles we can mark, okay? Another big one to mark yourself is anytime there's a shared side. If both triangles use the same side, mark it, okay? Anytime you see vocab, like if you see something like something is bisected or something's a midpoint, then you know things on either side can be marked. This is a big one. If they tell you you have parallel lines, then automatically from parallel lines, you should get some angles congruent, okay? So something like alternate interiors, corresponding, something to that effect. So look if you see parallel lines for some kind of angles that are congruent, okay? So these are things that we can mark that could make our triangles congruent. So I look at A here and I say, is there anything I can mark? It looks like they have some angles marked. And I see I have a big X there, so I can mark that third set of angles. All right. Is that enough to prove those triangles congruent? Angle, angle, angle. None of my sides are marked, okay? Angle, angle, angle is not a way we have learned, so we cannot do that. There's not enough info, so all we can say is because there's no sides known, we can say none, okay? We have to know at least one pair of sides. Okay, so let's look at B. On B, they have a couple of angles marked. Can I mark anything? There's not the X for the vertical angles, but they do seem to have a shared side. They both share this side, so I can mark it, and that gives me a set of sides. All right, so follow the order. You just kind of start at one. Okay, so I'm going to start at this corner and go around the circle, so I get angle, there's my gap, angle, and then the side. The side is outside the two angles. Angle, angle, side. So it looks like, yes, that one's going to be congruent by angle, angle, side. Okay? We get to the last one there over on C. And I always ask, can I mark anything myself? They have a pair of angles. They have a pair of sides. You're right, there's an X. So I could mark this vertical angles, okay? And when I look at that, I have three things marked. It looks like I might have enough. So I follow their order. I start down here, maybe angle, side, angle. Angle, side, angle. Okay, so this one's going to be angle, side, angle because the side is between the two angles that are marked. Okay? I can't stress enough. We're going to see those. We're going to see a lot of them because I'm just trying to see, do you know the difference between, right now, what are we up to? 5 different ways. We did side, side, side. We did side, angle, side, and then HL. And now today we have angle, angle, side, and angle, side, angle. Okay? All right. So here we are on this one. It says, can triangle STW, let me, STW, that's this one, and triangle VWT, are those two congruent? Okay? So we're trying to see, is there anything we know about those two triangles, okay? And in fact, I'm going to do a little, pull them apart just a little bit so you can see kind of what they are when they're not overlapping, okay? All right, so is there anything I can see that I could mark on both of them? All right, you see an angle of 60 and an angle of 60. So I can put this angle and this angle are definitely the same. Anything else? All right, you see a right angle down there at T and a right angle at W. So far, so good. 2 angles, that's good. You think you see some vertical angles. Okay, be careful. I see your vertical angles right here. Okay, but think about that. If I come over here, I'm talking about something just hanging out here in the middle, right? That's not really going to help me much because that's not part of the actual full blue triangle or the full red triangle. Okay, so that one's not going to be so helpful to me. See if I can maybe kind of erase that. All right, but it is a good vision if you can see that, but that one's not going to help us on this particular case, okay? So what else is there? In fact, I kind of need a side. Do they have any sides? Even though things look congruent, you're not allowed to always mark them, okay? But I hear you right there, right? This shared side down here. So this side down here is part of that. Are those triangles congruent? They are. Go around the circle, side, or angle, angle, side, angle, angle, side. So those are congruent by angle, angle, side, okay? So let's look at the bottom one. And let's see, it says angle STW again, so STW, right? And I see an angle here and a right angle here. And we'll go with the VWT over here, which has a right angle and that mark. All right, it looks like we have some angles. Is there anything we can mark? I'm with you there. It looks like we could mark that shared side, right? So if we mark that shared side, are those triangles congruent? And I would definitely say yes by, let's check the order here, angle, side, angle, angle, side, angle. So angle, side, angle, that side is definitely between my two angles to mark that, okay? All right, ready for the third page. All right, lots of stuff here in the margin. I copied and pasted it for you already, so you don't have to write it, right? So don't worry about that, okay? These are the 5 ways we've learned so far. We have side, 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 where you prove all 3 pairs of sides congruent, and then my triangle is congruent to my triangle, okay? For side, angle, side, the recipe, this is kind of my recipe box. I need to prove a side, an angle, and a side, and then my triangles are congruent. Remember, the order you do it in doesn't matter as long as it's done. For HL, don't forget, we have to prove that right triangle, prove one leg congruent, prove one hypotenuse congruent, and then my triangle is congruent, right? For angle, side, angle, we prove an angle, a side, and an angle, and that's how it's marked in the picture, remember. Doesn't have to be that way in the proof, and then my triangle is congruent to a triangle. Or angle, angle, side, where the side's not in between the 2 angles, and then my triangles are congruent to a triangle. So this is kind of my recipe box, right? If I follow one of these recipes in any order, obviously I have to do the sides before I can do the triangle. The triangle comes at the end, but you can do them in any order if you have that given information. So what I want to stress over and over and over is you want to make sure that you are looking for marking up your picture every way you can so you can decide in what's the best way to prove triangles congruent, okay? All right, so let's do this first flow proof. Okay, just look at this proof, okay? This is how things work a little bit. You see these bubbles. In these bubbles, we have some information, okay? And you'll notice underneath each bubble, there's a line, and on that line is where we're going to put the reason we can say what's in the bubble, okay? So the lines below the bubbles are kind of my reasons, and then what's in the bubble is the information I have, okay? So let's go ahead and look at what we're given. They tell us in the picture angle 1 is congruent to angle 4. They tell us that CF, this line right here, bisects angle ACE, so this big angle is bisected, so it looks like I would get some equal angles. And we're going to try to write a proof that proves that CBF, that's this one right here, is congruent to CDF, which is this one right here. Okay, kind of random, but that's where we're at, and that's what we're trying to do. It's not the whole picture. All right, so they start out and said angle 1 is congruent to angle 4. Well, how do we know that? Well, that's given. They tell us 1 and 2 are, and it's blank. So I go up to my picture, I look at 1 and 2. Well, 1 and 2 together up here looks like they are side by side. 3 and 4 are side by side. What do we call that when they are side by side in the form of line? Well, we're going to use the word supplementary. So 1 and 2 are supplementary. 3 and 4 are supplementary because they form that line. How do we know that? Don't look at how I spell because I'm not sure I spelled it correctly. Definition of supplementary. Remember, when a vocab word comes in, we define it. So, all right, so we have angle 1 congruent to 4, 1 and 2 are supplementary, 3 and 4 are supplementary, and then we have CF bisects ACE, and that was also given. Okay. When something is bisected, it gives you 2 equal pieces. Since my angle ACE was bisected, I'm looking up here at the top here. This angle up here was bisected. I get equal sides on either side. So like angle ACF, so that starts here, ACF coming down, so it looks like ECF would be the other one. And those angles are congruent by definition of bisector. Okay, by the way, that's a set of angles. All right, now, this is one thing with flow proofs that you can kind of see where this is going here. Notice over here that I get these arrows that say if 1's congruent to 4 and 1 and 2 are supplementary and 3 and 4 are supplementary, then, okay. So 1 and 4 are the same. Look up here. If 1 and 4 are the same, and we add something to 1 and get 180, we add something to 4 and get 180, doesn't that make sense that it's the exact same thing we're adding? So that means 2 and 3 are going to be congruent. And we did learn this back in chapter 2. I'm going to tell you honestly, we did not use it very much, so we haven't seen it. They call it the congruent supplement theorem. Basically, it means the supplements of congruent angles are congruent, okay? And that's where we get 2 congruent to 3. Okay, so this is another pair of angles. Let me come up to our picture, clean it up a little bit because I've got a lot going on there. Okay, so we know now that 2 is congruent to 3. We know that this angle up here was bisected. And we're trying to prove those triangles congruent. Okay, they give us one more there. CF's congruent to CF. They share that side in the middle. All right, what can we do? How do we call that when something's equal to itself? You look in the mirror and you see yourself. Reflexive. All right, that gives me a pair of sides. So are those triangles congruent? Yep, make sure you change this to triangles. I'm not sure why they have angles. Triangle CBF and triangle CDF are congruent. Let's look at the order. I have an angle, then a side. Angle, angle, side. It's not in between them, it's outside of them, so we're going to say it's by angle, angle, side. All right, flow proof. Because of these 3 things, we can prove angle, angle, side. So we kind of take these ideas, put them in bubbles, then arrow the bubbles to say, because of these 2 things, this happens, or because of these 3 things, this happens, that type of thing, okay? That's how a flow proof works. So let me do one more. We're going to do another flow proof, okay? You'll notice they didn't start us out here, so I'm going to help you fill it out. And we're going to see what we can prove. It says, suppose it's given that CF here bisects ACE, which is this top angle, and BFD, which is this angle. Write a flow proof to show that triangle CBF and CDF are congruent. So same triangles. I'm going to start out with my givens. CF bisects angle ACA. All right, I'm going to stop with that one. I'm just going to write 1 to start with. Okay, so look up here at ACE, this top angle. If this is bisected, then it means the left side, ACF, is going to be congruent to the right side, which is ECF. And how do I know that? Well, remember, I see this vocab, so it's definition of bisect. All right. Now, I didn't use all my givens, so I'm going to go ahead and write my second part of the given, which was CF bisects angle BFD. So that's this bottom angle down here where I have the 2 markings. If BFD is bisected, then I get 2 equal angles too. So I could call it, oh, by the way, that was given. I can call the one on the left BFC. And it's congruent to the one on the right, DFC. And that will give me, because again of bisect, definition of bisect. All right, quick check. Pair of angles, pair of angles. What else can we mark in that picture? And if we can mark it in the picture, we put it in the proof and say why we can mark it. You're right. We can mark that shared side right there in the middle. So we can say CF is congruent to CF. And the reason it is reflexive. It looked in the mirror and it saw itself. All right, that's a pair of sides. Do we have enough thrown into from our recipe to get a congruent set of triangles? We do. We are ready to say CBF. Wow, is congruent to triangle CDF. And the reason is angle, side, angle. All right. And now is where I need to apologize because I just got rolling and I didn't do a flow proof. Okay, so we're going to go back up and we're going to start a flow proof, okay? So if you already did this, just watch if you want. You don't have to erase what you did. I can easily erase, so I'm going to erase. But don't worry about it because I led you wrong there. So just watch again, and you can decide if you ever want to try a flow proof or not, okay? All right, I apologize. I got just rolling there and I forgot what we were doing. Okay, maybe I should stop doing my video and go do something else, right? Okay, I'm going to start out with my given. CF bisects angle ACE. This time I'm going to use both of them since they gave them to me both. And I'm going to put them in a little bubble together, and BFD. All right, here's my given, okay? And from that, I get two things. So there's my arrows, okay? So this is going to be the same thing I wrote before, just not in a two-column proof. So on the top, I had angle ACF congruent to angle DCF. And the reason for that was definition of bisect. All right. It gave me a second bubble over here of the bottom angles, BFC, congruent to DFC. And the reason was definition of bisect. All right, and what else can we mark? We said right there in the middle, CF congruent to CF. Okay, so I kind of bring that in. Notice I didn't arrow down because I brought that in from the picture, and that's from reflexive. Now, if I use this pair of angles, this set of sides, and this pair of angles, I am ready to say that CBF is congruent to CDF. All right, and the reason is I used an angle side angle. All right, I don't know, it's not bad, right? It kind of organizes, it shows you where the information's coming from. Sometimes on two-column proofs, we're jumping and I say, look back at line 2 for line 5, and it's kind of confusing where this just does these arrows, so it really like focuses on like, where did I get that information and what can it take me to? So it's not bad. If you like it, use it. If you don't like it, don't use it. It still says write down every step and write down a reason. It's just a different way of organizing it together. Okay? All right, last page. And I'm trying to remember if I even like these examples. Okay. It says, you and your friends are trying to find a flag hidden in the woods. Your friend is standing 75 feet away from you, and when facing each other, the angle from you to the flag is 72 degrees. And the angle from your friend to the flag is 53 degrees. Is there enough information to locate the flag? Okay. So the locations of you and your friends and the flag form a triangle. So you have the measures of one side, right? We have one side and two angles of the triangle, right? I know one side and that. Okay, so if you think about this, this is a set relationship of an angle, a side, and an angle. Okay, so by the angle, side, angle, all triangles with those same exact measurements are congruent. So we could find the flag using that angle, side, angle. Okay? Probably not the best example there. That's some of these story problems get a little bit hard to relate. On this one, on the theater, you're working two spotlights for a play. Two actors are standing apart from each other in the end of the spotlight, and the spotlights are located and pointed as shown. It says, can one of the actors move without requiring the spotlight to move and without changing the distance between the other actor? Okay? So if you think about it, what I'm saying here is we want one actor to move without requiring the spotlight to move, without changing the distance between the other actor. So right now, I have an angle, and a side, right? But if I move this actor, so what are ways I could move the actor? If I move this way, it's going to change this 20 side, right? If I move this way, it's going to change that 20 side. If I move this way, it's going to change that 20 side. And if I move this way, it's going to move it, right? So really, there's no way I can move that without changing that side. So because of that, it says, can they move without requiring it? I would say no, because on an angle side, I can't change that side. And that's the important thing. If that side changes, my relationship changes, right? All right, so really focusing here on what we can do to get this. Okay, and I'm not, yes, I did. I made you a worksheet on this one. I was like, do I have a worksheet? I do have a worksheet. 4.5 worksheet. You should have it. Pull that out of your notebook. Do your best to follow the directions on it. Please read the directions for each section so you know what it's asking for, what it's looking for. Because sometimes it's like if you're doing this by angle, side angle, which angles and sides should you use? You really need to pay attention to it, okay? So use the pictures drawn. If there isn't a picture, draw one. See if you can label it up to follow it, and do your best. If you have questions, let me know.